All right, guys, welcome to an AP Stats Cram review. All right, basically, I'm gonna go through each unit numerically. So it's gonna be 1 through 9, breaking down what you need to know. I'm gonna try to save some time, not waste some time. You know what I'm saying? You feel me? Getting into this unit, we're gonna be seeing mean, median, mode, range, box plots, dot plots, not histograms, histograms, yeah, and categorical data that represent, this graphs that represent data, one variable data. All right, so first you really need to know how to interpret most things, like interpreting a box plot, interpreting like range, median, mode, all of that. Okay, so we're going to use SOCs to describe these ranges, or distributions, I mean to say. So, which means this is the acronym for shape, outlier, center, and spread plus context. Because you need to add context, okay? Because just saying like, the center is just like 5. Now you gotta be like the center of the is 5. All right, now getting into the IQR rule. This is like the 1.5 IQR rule, right? Basically, you're gonna use this to find high and low outliers. So finding a low outlier is gonna be quartile 1 minus 1.5 times the IQR, which is the IQR is Q3 minus Q1. And then finding a high outlier is gonna be Q3 plus 1.5 times IQR. So if it's higher, it's going to be a high outlier. You feel me? All right, now we're going to learn how to get into the z-score. Okay, basically all you need to know is basically it's going to be, just remember value minus mean divided by standard deviation. This will be with you the rest of this course. Basically, the z-score is the number that tells you like your how many standard deviations you are from the mean of the graph. Like knowing it's a normal distribution. You can only use z-score if it's a normal distribution, right? It's like, oh, how do you get a normal distribution? All right, now we got to get into the least squared regressions line. Okay, so this basically is like regressions, like Desmos, or you take the SAT, all about regressions. This is regressions. You got to know how to interpret each variable, like y hat equals a plus or minus b. You got to know how to interpret each value, you know what I'm saying? So like the residual squared, slope, the y-intercept, a. Forgot to say, now we're into shit. Yeah. All right, now we're going to get into unit 2, okay? This is when we get into least squared regressions lines, two-way tables, mosaic plots, just graphs that use two, that represent like two variables. Okay, this is unit 2, two variable data. But you're gonna need to learn how to calculate, the LSRL, which is the least squares regression line. I'm not gonna say out loud because I have a list, but I can't lie. But calculate the coefficient and just learn how to interpret looking at this data you're given. Okay. But that unit's only like what? Like 5 to 7%. Let me check. 5 to 7% of your exam. So I wouldn't worry too much. It's like 2 to 3 questions. All right, now getting into unit 3. This is collecting data, right? This is like, it's going to give you suggestions like how are you going to collect this? How was this collected? What's the most efficient way? What's the most non-biased way? Okay, now we're going to learn what sampling methods are biased, lead to bias, and sampling methods that, are acceptable. So basically all you need to know, convenient sample, voluntary, response sampling, those are going to be the biased types of samplings. Because convenience, like, oh, it's the easiest people you can just talk to. Like, let me get you. Voluntary is like, oh, people volunteer, so it might be like, yeah, let me just like sign myself up for a program to get my fear of arachnophobia. Like that's gonna lead to some bias because like that's like self-driving them trying to get in that data. But you're gonna need to learn how to break down, how to construct a simple random sample. Okay, at SRS we can say. You're basically gonna label each individual, randomize, and select. Okay, selecting how much it's gonna say. That's the 3. All right, now there's different variations of SRS, right? There's stratified, there's cluster sampling, right? Cluster is like location, like, oh, let me get this this cluster of people from over here. Stratified is just like a group of people, right? You get one population, you break it off, right? So they're similar, but you're gonna put them in stratas. That's why it's called stratified. Each little group is called a strata. All right, now you got to know what a control group is. Okay, we're still in Unit 4. It's basically this group in the experiment received no treatment, so you can compare it to the other groups that had treatment. Now we got to know the word treatment. Treatment is just like a specific effect applied to the people, individuals. All right, now we're getting into the unit of doom. Okay, this is going to be worth 10 to 20% of your exam, and it's probability. Okay, so notation is really important. Okay, you got to know when to put or how to put the P parentheses A U B A N B, which is like the U, and or. All right, but most of these conditions that people get stumped on, it's going to be in the formula sheet. General addition rule. It's going to be P parentheses A plus P parentheses B minus P and B. But we also got to know the term mutually exclusive. Basically, that means two events cannot happen at the same time. So it's like, what's the probability of me being at my house and me being at school at the same time? It's going to be 0. Like, that can't happen. That's going to be mutually exclusive. But basically, you want to know the notations of probability, right? You will put the P in front of it, put parentheses. The N shape is going to be and, multiplication. The U is going to be or, addition. The lines is going to be given. So that's the conditional probability. So if it's P parentheses B line A given A, so that means what's the probability of like me eating an ice cream given that it's a hot day? Like, and so the other one would be like, what's the probability of me eating ice cream and it's a cold day, given it's a cold day? What's going to be higher? Probably the summer because it's hot. We are still not done with Unit 4. We have to get into the discrete, binomial, and geometric random variables. Okay, we're going to learn how to you need to know when it is to use that formula, that big nasty formula. Okay. Discrete variable is basically just like it's going to be in counting numbers. Like it can change like 1, 2, 3, 4, 5, 6, 7, 10. I might be wrong. Don't call me actually. But discrete random variables will be given to you on the formula sheet. That formula will be given. Okay, so I wouldn't worry about too much, but it's basically just summation of xi minus probability of xi, which is, think of it. All right, now getting into binomial distribution. Basically, this only has 2 outcomes, success or failure. Okay, and it has to meet the rules. Think of BINS, right? Acronym for binaries for like 2. Right? Independence I, and then N for like N equals boom. So that means like set number of trials. It has to have a set number of trials. It can't be infinite amount of trials. It has to be set for binary. And then S for same probability. So each thing has the same probability. All right, now getting into geometric distribution, right? This is when it's like how many tries until the success is gonna hit. The first success is gonna hit, right? It's gonna be fail, success. Boom. How like what's the probability of getting that boom first try? Kind of. Just know you have to know geometric distributions will always be skewed to the right. Just think about it. The farther you go, like it's not gonna have much. But basically, sum it up. Just know the difference between binomial, geometric, know the formulas, know how to interpret, and just calculate the probabilities using the formulas they give you. Okay, now getting into Unit 5 and 6, I'm going to combine these two together because they're basically kind of just, they can mesh together. But together, like maximum percentage this can happen on the AP exam is going to be like 27% of your exam. Right, that's the maximum percentage, right? Okay, so basically, we're getting into sampling distributions and what types. Okay, so this is when you get into the parameter statistics like p, mu, theta, p hat, x bar, s sub x. Unit 5, you're just learning how to describe these sampling distributions, right? And just like proving something like that, right? Knowing the conditions, right? Randomize, 10% rule, independence, and large counts. And for proportions, large counts is going to be NP, which is n times p, is greater than 10, and n parentheses 1 minus p is also greater than 10. Okay, if it doesn't meet, I forgot, but it doesn't meet. Okay, now trying to meet the conditions for means is going to be a little different. It's going to be the same two conditions, random and 10% independence, but you can use CLT, which basically is central limit theorem, which is n is greater than equal to 30. All right, now we're about to get to the unit 6 portion. This is like confidence intervals, critical values, p-values, all of that. Okay, p-value is going to be z. Remember that from the past units. Okay, confidence interval is going to be, the base formula is going to be point estimate is equal to, well, no. Confidence interval is equal to point estimate plus or minus, right? You want to get the plus, minus, you want the left or right. Critical value, which is T star or Z star, depending on, I'm going to get into that later, times margin of error. If you don't know what this stuff is, please do more review. All right, so we want to use t-tests for means and z-tests for proportions. You're like, man, why is it different? I don't know. But just letting you guys know, units, these units, 5 and 6, will be in FRQ, and you will need to know the procedure of state plan do conclude, which is a fat little genre. Okay, diving into the significance test, right? Test statistic, which is basically the z-score, right? It's just going to be stat minus parameter over or slash divided by standard deviation. This is also state plan do conclude. You're going to need to know how to do this. So obviously in state, you're going to have parameters, statistic, significance level slash alpha. Plan is going to be procedure, the conditions you have, and, like procedures like z-test, t-test, sample for one sample, okay? For do, a lot of people do it differently, but I was trained to write down the general formula, specific formula, work, the picture of the graph, p-value. Just saying. And I'm getting to conclude. You got to know how to decide your decision, right? It's going to be accept or reject the hoe. Do you have convincing evidence? And basically, you want to reject the hoe if your p-value is lower than the hoe. So if it's lower than hoe, you reject that hoe. But if it's higher than the hoe, you fail to reject the hoe. So you accept the hoe. Hoe basically means null hypothesis, which is the one that was the first. If you see, you should know this. All right, now getting to interpretations, right? I see a lot of people mess up on this. If you reject the hoe, you have convincing evidence for the alternative. Okay, so it's like, since p-value of is higher than 0.05, well, is lower than 0.05, we're gonna reject the hoe. We do have convincing evidence that the alternative hypothesis is true. All right, now we're getting to the type of errors. This will be asked for sure. It's gonna be, so type 1 error is basically you reject the hoe, but it turns out it's true. And then type 2 error is like you believe the hoe, but she was lying. All right, so basically think of type 1 error, right? Think of the number 1, like I rejected the hoe. Like they look alike. I rejected the hoe, but she turned out to be true. So it's basically just like polar opposites, positive, negative, negative, positive. All right, now getting into unit 7. This is gonna be a pretty heavy unit considering it's 10 to 18% of your test, okay? This is using t-distribution to test and estimate means. Both 1 sample, 2 sample, okay? I just realized I can't really get that much into this unit because I kind of explained it earlier. If you don't know how to apply means into your thing yet, it's a little too late. That's what I'm saying. But you just got to know T confidence interval is different. Okay, so basically, well, we're introduced into this mean this T distribution is like degrees of freedom. It's like, yo, what the heck is that? Is that like the patriotic new unit? Nah. It's basically, depending on the thing, it's going to be the the population minus something, right? For one sample t, it's gonna be df equals n minus 1. I'm not gonna get into too much detail about this stuff, but a lot of the notations and stuff you could be looking for is in the formula sheet, and I just recommend getting familiar with all the new letters and symbols you're seeing. Okay, so all right, I'm gonna try to get these two. I'm trying to combine these two units. All right, it's gonna be unit 8 and 9, the last two. Basically, all right, oh fuck. Oh, unit 8 and 9 only each are only going to be 2% to 5% of your exam. Okay, so that's basically only 0.8 of a question to 2 questions. Sounds good. Okay, because this is the units of doom. Okay, we're getting into chi-square tests, and I honestly did not like these. Like everyone was getting it but me. Okay, but there's 3 different tests for chi-square. Okay, there's goodness of fit, homogeneity, and independence. Okay, goodness of fit is going to consist of 1 sample, 1 variable. Homogeneity is going to be 2 samples, 1 variable. And independence is going to be 1 sample, 2 variables. Okay, this will make sense later. All right. So goodness of fit, you're basically like, the hypothesis is the claim distribution is true. So the claim is like, oh, the distribution is going to be like this, right? When like the actual one you're about to make is going to be like this. You know what I'm saying? You're trying to prove if it's really true. Like, does it match what this guy's saying? They're usually going to have all the same proportions, if that makes sense, or a fixed or given proportions. Like, proportions are expected to follow the given values. I might have worded that a little weird. All right, now we're going to learn how to, like, what is chi-squared? What is this x to the power of 2? Okay, so basically, the formula is going to be summation, which means adding all up, observed values minus expected values to the power, right? Parentheses. To the power of 2 squared. Okay. Observed minus expected squared divided by expected. And you're like, damn, how do I find expected then? If the observed is given to me. Expected value, okay, how to find expected? Now we're going to do n times p, right? It's basically just whatever n is and the probability it matches with. That's the expected value. All right, now getting to the conditions, it's going to be the same 2, random and independent, 10%, whatever. Now the large count is going to be different. It's going to be all of the expected values. Each one has to be greater than or equal to 5. Ooh, it's like, why is it not 30? Why is it not 10? I don't know. But easy trick, find the smallest expected value. If it's greater than 5, the rest have to be greater than 5, right? Because it's the smallest value. If the smallest one, it's always going to be smaller than that. You feel me? Okay. I don't have a really good, clear drawing, but I'm not going to show you. Think of this. A graph skewed to the right, chi-square is right in the middle, and it's all shaded to the right. So it's getting the small area of the graph that's skewed. That's what a chi-square graph is usually going to look like. I don't know the science behind it, but something I guess you need to know. Oh, this is for goodness of fit, by the way. Okay, now getting to the chi-square test for homogeneity. This is going to be the one, 2 samples, 1 variable. Okay, so this is going to be like, is there a difference between the variable for population 1 and population 2? Right. So the hypothesis is going to be there is no difference in the categorical variable distribution for population 1 and population 2. The alternative hypothesis is going to be there is a difference in the variable from 1 to 2. All right, now getting into the expected value, it's going to be row total times column total divided by table total. I wish I had a graphic, but I don't know how to edit, so, and it's pretty late, and the test is tomorrow, so I'm going to do it. And now you're asking, like, how do you find the degrees of freedom for this test for homogeneity? Is it the same as n minus 1? No, it's going to be rows minus 1 times columns minus 1. A little switch up. I don't know where they pulled that from. All right, now getting into the chi-square test for independence, right? This is one sample, 2 variables, right? So this is like a population of people, 2 different things they can be put in, right? Independence, asking like, does it affect this? So it's basically looking for, does variable 1 affect variable A, or does it have an association? Okay, so the null hypothesis will be there is no association between variable 1 and variable 2. The alternative would be there is an association between the 2 variables in this population. Okay. Not much going on there. State plan, do conclude, do all that FRQ stuff that we learned in unit 5, 6. On to the next one. All right, getting to the last unit. This was unit of doom and despair. Thank goodness it's only 2 to 5% of this test, okay? But you're basically, it's called inference for quantitative data slopes. So you're basically diving into the LSRL slopes, which is kind of interesting. So you're just investigating how it can be used to, how the LSRL line can be used to estimate the slope of the other regression line. I can't lie to y'all, I'm not pretty too tech in this unit, okay? But conditions will be in the acronym of linear, which means it's linear, it's independent, it's normal, no strong skews, no outliers, equal standard deviation between residual plots. You know, it doesn't look like a sideways Christmas tree. Like it looks like, you know what I'm saying? And then random explains itself. But in this unit, we're introduced a whole bunch of new, I mean, not new, but we're getting into like population stuff. So that you're using 2 different symbols for like everything. Like, you know what I'm saying? Like parameter, statistic. There's not much going on here, but you got to know how to read the LSRL line, the graph, the interpretation of the standard error of B, which is going to be the slope of the sample. Slope of the sample LSRL typically varies from the slope of the population LSRL by the standard error of B. See, that was a lot of stuff, but quick tip. If it has anything about variation, like standard deviation, standard error, the interpretation is going to have typically. So associate that with typically. So it's going to be like the of the typically varies by the mean. Or this is applying to all other units. But this last unit, it's kind of just like you're applying these past unit skills and putting it here. Like you're still using confidence interval, hypothesis, all that, like PE plus or minus MOE, which is margin of error. Not much going on. All right, now to the big part. I'm not sure if this will even be on the AP test, but it's going to be beta equals 0, which is the population, which is the slope's population, the slope of the population. And the alternative is going to be B. It could be beta is less than 0, which means it's negative. B is greater than 0, which is positive. Or B does not even equal 0, which means it just doesn't match. Now you're asking like, what's the procedure called? One sample t-test for slope. Because it's one sample, you're doing a t-test for the slope. Damn. But you're basically just going to apply the same stuff from last unit. Test statistic is going to be, T equals stat minus parameter over standard deviation. So it's going to be B minus beta over standard error of B. I wouldn't worry too much about this unit or also I was talking about unit 8 and 9 in the AP test. So happy study. All right, guys, that is my AP review Cram, AP stats Cram review. All right, everybody, thanks for staying to the end. This is my AP Stats Cram review. I hope this helped you, at least a little bit. And